Second part of solving equations. So this is for all solutions, no matter how many times you might go around the circle or in which direction you're moving. And when you're doing this, you want to find all solutions without using a calculator. So you have to draw a picture to help you solve it. Now, first question. It's the same pattern or the same process of how you find out your solution like we did when we had the interval from 0 to 2 pi. So I'm first going to add over my 1 and divide by 2, so I have cosine x is equal to 1/2. Now again, I still draw my coordinate grid. All sad turtles cry. So this is where my two equation or my two things are. So I have my adjacent and my hypotenuse and my hypotenuse. So this would be a square root of 3 because I don't have a square root 2. I just have a normal 2. Not a square root 2, but a normal 2. So my angle here across from it, square root 3 would be a 60. Across from square root 3 is a 60. So my two angles that I'm dealing with is this one, which is the same thing as pi over 3. And I also have this angle right here, which is 300, which is the same thing as 5 pi over 3. Now, how do we represent it for all solutions? Now, if you think about it, I'm going to pick a new color here. If you think about it, it's saying that this is an answer, but also this is an answer. So I drew another circle. And then also 2 times around would be an answer. So that's just working with the pi over 3. So you're basically adding a circle. So this is my original angle, and then you add 2 pi n, where n is any number of revolutions, so any number of times you do a circle around your unit circle. So that was my one answer. That was just using the pi over 3. That was the 60 degrees. But I also have the 5 pi over 3. And it's the same concept here, plus 2 pi n, because it's the same thing as if I started in looking at my angle. Now I'm going to do it in orange. So this is 1, but I could also have gone around 1 and then have that one. It kind of looks squiggly. But here are my two answers again, because when you're adding on a circle, one circle is 2 pi, and you have the n because it's telling you how many times you should add on a circle. And same as solving like the last section, the first thing I'm going to do, I see a cosecant squared and a cosecant, so I'm probably going to have to factor. So I'm going to move over that too. So cosecant squared x minus cosecant x minus 2 equals 0. So factoring. So cosecant x and cosecant x. So two numbers that multiply to get -2, but add together to get a -1. So that would be a -2 and a +1. So factoring because, again, two numbers that multiply to get -2 and add together to get that -1. So now I can set both of these equal to 0. Now I'm not going to change it to my other trig functions until it's all by itself. So these are what I have so far. But now I want to actually change it to sine, cosine, tangent, and the reciprocal of cosecant would be sine. So this would be 1 over sine x is equal to 2. 1 over sine x is equal to -1. So you want to flip-flop both of those. This is like over 1. This is over 1. So you flip-flop both. So this is sine x is equal to, I'm sorry, this is over 1. 1/2. The sine x, this is still going to be equal to -1. So now I'm going to draw my two separate graphs. Or actually, I'm going to draw them all on the same graph. The reason why I'm going to draw them on the same graph is because we might be able to shorten up our answer. So I have, whoopsies. Here's my graph. All sad turtles cry, and plus I have sine is -1. With sine is -1, that's your y value at -1, so this is this point right here. So this is 0, -1. And my sign for negative, or for 1/2 is my opposite over my hypotenuse, my opposite over my hypotenuse. This is square root 3 again, because my hypotenuse is a 2, not a square root 2. So this angle is 30. This angle is 30. So when I'm finding my angles, I have 30. My next angle would be equal to 150. And my next angle would be, well, this is 3 pi over 2. However, when you want to look at the distance, you want to see if your reference angles are the same distance apart of each other. So these are my reference angles. You want to figure out the distance in between each of those lines. So my degree here, this degree is equal to 120 degrees, because if this is 30 and the whole thing is 150, if I subtract those two, that equals 120. The distance here, this is 30. So again, first I'm going to solve for tangent. So I have tangent squared, add the 1, divide by 3, add the 1, divide by 3, now take the square root. So I'm dealing with tangent squared x, oopsies, sorry, not squared, tangent x, because I'm going to take the square root of it, is equal to positive negative 1 square root 3. Positive negative 1 square root 3. Now I'm first going to draw them all in the same, and then look at my rotation between all of them. So I have one in each corner, because I have a positive negative, because typically if I just have one or the other, yes. So my opposite is 1, my adjacent is square root 3. Opposite is 1, adjacent is square root 3. Negative 1, negative 1. So the angle that I'm dealing with, my opposite of 1, it would be 30 degrees. And my reference angles are 30 degrees. So what I'm actually going to first do is look at what is the angle distance in between my transversal. So again, in between this line, this line, this line, this line. So if I first look at in between these two lines, a straight line is 180, but you're taking away the two 30s, so this would be 120 degrees in between there. In between these two is 60, that doesn't match. In between these two would be 120. And I know what you're thinking right now. Well, it's still kind of a pattern, but in order to write in the shortened up equation, you have to have the exact same distance in between. However, if I actually now split up my two equations, so I draw these two here, draw these two here. Again, these angles are still going to be 30 degrees. But now when you look at them to figure out the distance in between them all, in between your transversal, this is 180 degrees and this is 180 degrees. So these could be the same equation. Same thing here. When you're looking between these two lines, this is 180 and this is 180. So yes, this green one that I first tested showed a pattern, but it has to be the same. So if you see a pattern but not the exact same, try to split it up and see if that then creates a different pattern. So now when I'm starting these two off, I look at my first angle here. This is pi over 6. Pi over 6. And then you're going to add, in this case, this is a rotation of 180 degrees. So that's the same thing as pi. So this is pi n, because in order to go in between those two is a rotation of pi. So looking at this one, this is your first angle that you're dealing with, this angle right here. So this is 30, so this is 150, and if I change that, I would get that first angle is 5 pi over 6. And again, my rotation still in between those two angles is pi. That's the difference in between them, so it would be pi n. So these two equations are my answer. So when you're checking to see if you can shorten up your answer, you can if you have the same degree measurement or radian measurement in between your transversals. And the last one. So I don't see anything squared. Usually if I don't see anything, or if I see something squared, I can try to use any identities. I don't see that. However, I do know I can rewrite this as 2 sine x minus 1 over sine. I know secant is the the reciprocal of 1 over sine. If this happens now I have all of sines, but I don't want to have that sign in the bottom. I'm going to multiply this whole thing by sine x. That means I'm going to distribute to each and every term. So this first term becomes 2 sine squared x, because sine times sine is sine squared. The second one becomes sine over sine, which is the same thing as 1. And the third is 0 times sine is still 0. So now I'm going to solve for this. So sine squared x is equal to 1/2. Take the square root, so sine x is equal to 1 over the square root of 2. Now I'm going to be using that information. Sine x equals, oopsies, I took the square root, this should be a plus or minus. Plus or minus. So I have 1 in each quadrant, and I see a square root 2. If I see a square root 2, that's going to be a 45, 45. So my opposite is positive, positive, or negative, negative. So this is going to be positive, negative, and my hypotenuse is square root 2. So if it's a square root 2, that means my reference angle, or my angle, is 45 degrees. So this is 45. All of my reference angles are 45. So I'm going to check in between each of my lines. So this would be 90 degrees. This, between these two, is 90 degrees. And between these two is 90 degrees. Oh, by golly, between these two are 90 degrees. That means I can just write out one equation. I start with my first angle right here, so 45 degrees in radian measurement. 45 degrees in radian measurement is pi over 4. And then I'm going to add, again, my rotation here is 90. So I could change 90 into radian measure, which is pi over 2. And since my rotation is 90, this is the one that has n with it. So however many times I have a rotation, it's pi over 4 plus pi over 2n. And it's pi over 2 because this is the same thing as 90 degrees. And my rotation in between each and every angle is 90 degrees. There you go, all stars. Have a great, grand, wonderful day.